All right, welcome CSEC scholars. Welcome back to our live class. Tonight we're going to be looking at some of the more common formulae used in CSEC math. As a matter of fact, these formulae are written or printed on the second page of the CSEC paper 2. As far as I have been from the days when I was doing CSEC, which is a long time ago, that has been the case. All right, so students go into the exam and they don't even realize that these formulae are there for them to use. So we're going to be focusing on those particular formulae tonight, the ones that are printed on the second page of the CSEC paper 2 paper. And as we go along in this series, so this is the Thursday evening series, we're going to be looking at the other way and how they are derived and when to use them and the shortcuts that we can take. All right, so that's what we're going to be doing tonight. Hello, CSECs. I know you are busy preparing for your math test and your CSEC exams coming up. I have a very important question to ask you. Do you like moon hat? Thank you. Another important question. Have you ever gotten a problem wrong simply because of making one little mistake? I'm sure you have, as thousands of make with all the topics in CSEC math. We're going to look at common errors, everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. All right. All right. So welcome again. And we're going to go right into our formulae. Are you hearing me loud and clear? We just wrapped up a live pep session and it wasn't going so well. Okay, I'm getting the thumbs up from my studio crew. So they're hearing me loud and clear. All right, so thumbs up and off we go. So I need now to go to... So this is the slide, okay? So it's CSEC math, formulae, and shortcuts. I have not shared my screen. Give me a second. Let me share the screen. All right, so that's our screen. All right, that's our screen. Studio crew, are you ready? All right, my studio crew is ready. Here we go. So the first slide, all right. Now, these are the formulae that are on the CSEC math paper 2. As you flip the first page to the second page, this is what you see. And believe me, students are so anxious to dive right into the paper, just to see if everything that they have been preparing for and working out and swatting, and they want to make sure that it's there. So they skip past this very, very, very important page, not realizing all the useful information that is there. So we're going to break down, I'm going to separate each of these formulae and just tell you briefly what each one is for. And you're going to be saying, oh my God, I didn't know that that was even there, that I could even use it, right? As we go further in this series, I'm going to look at each one separately and show you how the formula was derived, when to use it, and some shortcuts. So here we go. We're looking at the very first one, and that is the circumference and area of the circle. All right, good evening to those who are joining. Remember, as you come in, very good, thank you, not just to Miss, but fellow scholars who are here. So the first formula equals pi r squared, where r is the radius of the circle. So here we have 3 diagrams of the circle. A, area. So to find the area of the circle, it's pi r squared, where r is the radius of the circle. Now, if you look at the first circle, that line that you see going from the center to the edge of the circle, that line is called the radius, and there are countless radii in the circle, because you can draw a line from the center to the end all over the circle. There are many, many, many infinite radii in the circle or on the circle. So any line from the center to the edge of the circle is the radius. Now, 2 radii would make a diameter if they are heading, if they are continuous. So 2 radii being continuous would create a line from one end of the circle across the center to the other end, and we call that the diameter. So the diameter is 2 times the radius. So the formula says if we want to find the area of a circle, we square the radius and multiply it by pi. Now, what is pi? Pi, and we're going to look at pi separately as a special number used in mathematics. We're going to look at how, and this is in other lessons, because in this Thursday night class at this time, we focus on formula. So we're going to look at, yes, John?
This pi can be written as 22/7 or 3.14.
That's absolutely correct. Thank you, John. So pi in fraction form is 22/7, and in decimal form is 3.14. As I was saying, we're going to look at how we come by that, how we come to say pi is that value. We're going to look all at that and more. So for now, we're going to take it for granted that pi is 22/7 or 3.14. So once you know the radius of the circle and you are asked to find the area of that circle, the total space covered up by the base of that circle, it's 22/7 times the radius times the radius. Because when you square something, you multiply it by itself. Suppose they give you the diameter and they want the area. Since the radius is half of the diameter, we would half the diameter first to get the radius, and then square it and multiply it by pi. All right. Now, the circumference is the distance around the edge of the circle. And so the formula for the circumference is not here, but you should know it. It's 2 pi r. So 2 times pi times the radius. And the circumference divided by pi will give you the diameter. Likewise, the circumference divided by the diameter will give you pi. Now, let's look at the second formula, and that is the area of the trapezium. All right, area of the trapezium. The shape that we're looking at is a trapezium. It has one pair of parallel sides and one pair of sides that are not parallel to each other. So in this case, the pair of parallel sides would be the 15 meters and the 7 meters. You notice the two right angles at the corners there, right? So if two right angles are formed in that way, it tells you that the two lines heading down from it are parallel to each other. So the 15 and 7 are parallel. So the formula says the area of the trapezium is half bracket a plus b times h, where a and b are the lengths of the parallel sides and h is the perpendicular distance between the parallel sides. So the height would be 15 meters. That's the distance between the 15 and the 7. Remember, the length is considered the distance between the two parallel sides. The height is the distance between the two parallel sides. Now you might be asking, but what am I supposed to do with the 17? No, this is a common mistake that persons make, thinking that once a number is there in the problem, you need to use the number. No, you don't. Just because it's there doesn't mean that you have to do anything with it. If you don't need it, you don't need it. So all we need to find the area of this trapezium is to add the two parallel sides. So 15 plus 7, and that will give us 22 meters. We're to find a half of that, or divide it by 2, which will give 11 meters. And then we're to multiply it by the distance between the two parallel sides, otherwise called the height, which is 15. All right, so that's what? 11 times 15, and that gives us 165 meters square. Remember, it's area, so the unit is meters square in this case. The next formula on the CSEC is what we call the quadratic formula. Ajani is saying he thought class was done. Ajani, this is CSEC math class. The PEP class abruptly because we had some issues with the sound, and it ended abruptly. You can stay if you like, but the PEP class has ended. Right, scholars. So this is what we call the quadratic formula. I'm hoping that you can make out the right, which I have demonstrated how to use the formula. So the quadratic formula is used to solve any quadratic equation. There in algebra and in other topics in math, there are several methods that we can use to find the solutions for a quadratic equation. We can factorize, we can use a graphical method, we can use matrices method, right? There are several things we can do. But not all quadratic equations can be factorized. However, this quadratic formula can be used to solve any quadratic equation. So if you try factorizing and it can't be done, you can always go to the quadratic formula and you will get your solution. Now, the quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. What is a, what is b, what is c? We need to know what are the values here to substitute into the equation. So a would be the coefficient of the x squared term. B, and by coefficient I mean the number that is in front of the variable. So in the formula here, they are using all variables, but bear in mind the a, b, and c normally would be represented by numbers. So a would be the number that's in front of the x squared, or the coefficient of the x squared. B would be the coefficient of the x term, and c would be the constant term. If you are given a quadratic equation and it is not yet in the standard form as this, you have to first put it in the standard form where we have a descending order of powers with the variables, like the square first, then the x to the power of 1, which we don't normally write the 1, and then the x to the power of 0, which is a constant term. We have to put it in order before we can allocate to say A is what, B is what, C is what. And then we plug those or substitute those into the formula, and then we just solve the formula. So I'm hoping you can see the image on the right. I'm going to be reading it for you. So the equation that was given was negative 2x squared minus x plus 10 equals 0. So it's already in the format of the quadratic. So A, the coefficient of the x squared term is negative 2. B, the coefficient of the x term is negative 1. And C is 10. So we just plug those values into the quadratic formula and we get x equal 1 plus or minus. Now, why do we have the plus or minus? At a point in the solution, we're going to split the working out into two parts, because when we solve a quadratic equation, we get two values for x, because the quadratic equation produces a parabola which most times cuts the x-axis at 2 points, which give the solutions. It can cut it at one place, in which case we would have the exact same values for x. When we are doing this formula by itself, we'll go more in depth to how the formula was derived and so on. But for now, just take it for granted that that is the case. So we plug that in. Under the square root, we have negative 1. Be sure to put that in bracket because you're going to be squaring that negative number. If you don't put a bracket, so if you just had the negative 1 square without the bracket, if you were to punch that in on your calculator, you would get a negative 1, which would be incorrect. The square of negative 1 is a positive 1. And then we have minus 4 times negative 2 times 10. So when we work out all of that under the square root sign, we get 1 plus 80, which is 81, the square root of which is 9. So it's x equal 1 plus or minus 9, and the 2 times negative 2 down the denominator give negative 4. So now we branch off. We're going to add the 9 to the 1 and divide by negative 4, which gives negative 5 over 2. And we're going to subtract the 9 from the 1 and divide that by negative 4. All right, so we get positive 2 and negative 5 over 2. Do you have any questions, those in studio? And do you have any questions regarding the quadratic formula? Everybody good on that?
Yes,
Welcome back, Anusha, again. Everybody good on the... And we more in depth when we're doing these formula, we're devoting an entire class to each formula so you can see how it's derived. Why do we run for this formula? Remember, these formulae down to us, and we are so fortunate to this time where you can take up a mathematics textbook, hundreds of us, and not realizing that these were done to us from all over the world, right throughout the centuries and even millennia. And now we can have it all in one place for our use, at our disposal. We really take it for granted. Some of these formulae, mathematicians, their entire lifetime in some cases, or several persons working at this for their entire career, trial and error and experiments, late nights and all of that, before they finally derived the formula. And now we take it for granted, and we shouldn't. We should show our appreciation and use them to help us to solve our problem in mathematics. Next one, and that is, okay, roots. No, I have the wrong thing here. I think this is the one. Let me make sure I'm not skipping any. So that one. All right, so these are the trigonometric ratios. Okay. All right, trigonometric ratios. So these are our sine, cosine, and tangent, more belovedly called the trig ratios. So these, we can apply these to right angle triangles. And here we have on the image, we have an example of a right angle triangle. You see the famous box in the corner, as we refer to it. The famous box. Once you see that box, you know it's a right angle triangle. You know you're looking at a 90-degree angle. Every other angle has a curve like that other angle you see there in the corner. And by the way, that symbol there inside the curve, that is called theta. It's a Greek symbol. In mathematics, we use it to represent the unknown angle. In the right angle triangle, the longest side is the hypotenuse, as you can see on the diagram. And the opposite and adjacent sides vary depending on which angle you are referring to. So for this theta, this unknown angle in this diagram, the side labeled opposite is opposite to that angle. And the side labeled adjacent is adjacent or touching that angle. But if we were referring to the other acute angle, which is not labeled in this case, but the other acute angle to the right top, then the side that is now adjacent would be opposite to that angle, and the side that is now opposite would be adjacent. So the adjacent and opposite are not fixed in terms of labeling. They depend on where the angle is that we are referring to at that particular time. But once you identify your hypotenuse, your opposite, and your adjacent for any given right angle triangle, you can go ahead and decide which of the trig ratios you need to apply to solve your problem. So here are the trig ratios. For sine, the sine of an angle is the opposite side over the hypotenuse. So if you are given the angle and you are given the opposite, and you want the hypotenuse, or you're given the hypotenuse, you want the opposite, you just plug in the two that you know and you solve for the unknown. For cosine, the cosine of an angle is the adjacent side over the hypotenuse. And for tangent, The tan of an angle is the opposite side over the adjacent. Now there is an abbreviation that we use, SOHCAHTOA. So SOHCAHTOA, SOHCAHTOA. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So you can use that to remind you. And if it is the angle that you want to find and not a missing side, then you would use whichever of the ratios, depending on the sides you're given. But to find the angle, you would press the inverse or shift or second function on your calculator and do the operation with your division, whichever of the ratios you deem appropriate for that triangle, and then you will get the angle. So the inverse, second function, shift key, whichever one calculator has, will produce that effect for you if you want the angle as opposed to the side. All right, so we're moving on. So the next formula or set of formula, volume is equal to the area times the height, where A is the area of a cross section and height is the perpendicular length. All right, now what is that saying? The concept of volume or capacity, how much space is on the inside of the three-dimensional object. How much can you pour into it? How much will it hold? That's the concept of volume. And with the of volume, you would find area of the base multiplied by the height. And it's particularly so for prisms. Prism is a three-dimensional shape where the base and the top have the same shape. So for example, the circular prism, which is this circular base, circular top, and then it's connected by the height. The square prism is the cube, and rectangular prism is the cuboid, and so on. Angular prism. So once the top and base are the same shape and they're connected by straight lines, we have a prism form. And the idea is first find the area of the base. So if it is a circular base, you would find the area of the circle, pi r squared, and multiply that by the height to get the volume. If it's a rectangular base or a square base, you'd find the area of that base, length times width, or length squared, and multiply it by the height. Triangular base, you would find the area of the triangle, whatever kind of triangle it is, and multiply it by the height. So that is the concept behind volume. So, all right, so we said the volume of the cylinder, likewise. Since the cylinder has a circular base, then we would find the area of the circle, pi r squared, and multiply it by the height, and we will get the volume of the cylinder. And that is the perpendicular height, straight from the base to the top, not the slant measurement. This is another common error, person's mistake. The slant measurement, particularly for triangles, they mistake that for the height. The height is the straight distance from the base to the top. And the volume of the right pyramid is 1/3 the area times the height, where A is the area of the base and H is the perpendicular height. All right, so let's go on. Now we're looking at area of the triangle, and at the CSEC level, there are 3 formulae that are used to calculate the area of a triangle, and it depends on what type of triangle it is, and it depends on what information you are given. The most commonly known formula for area of the triangle is half base times height, where the base is the length of the bottom of the triangle, for want of a better word, and the height is the perpendicular distance. So from the base to the apex, not the slant measurement, not the hypotenuse or not any slant measurement. Straight up from the base to the apex. So it's half base times height. If you are given a triangle that's not a right angle triangle, you have to look to see if the height is given, and the height would be an interior measurement from the base to the apex. For the right angle triangle, because it has a right angle, then you have the height there for that. That straight side going up would be your height. But like a scalene, equilateral, isosceles triangle, you have to be given the height. It's different from the lines that run along the perimeter of these triangles. If you are not given the height or you don't know the base, then you have to use another formula to find the area of the triangle. So this next formula is half AB sine C, where A and B are 2 lengths of the triangle and C is the angle between those 2 lengths. So if you know 2 sides of a triangle and you know the angle between those 2 sides, you can use this formula, half A times B times the sine of the angle between them. Another formula for finding the area of the triangle is called Heron's formula. It's a little, it's long, several steps, and this is if you know the 3 sides of the triangle and you want to find the area. So let's say you know the 3 sides, A, B, and C. The first thing you would do is to get the semi-perimeter, which is to add them up and divide by 2. Then you're going to subtract each side from the semi-perimeter, and those 3 answers that you get, you're going to multiply them by each other times the semi-perimeter. So that's 4 things being multiplied, and then you find the square root of that, which is long-winded. And so if you are given the height and the base, or if you know the angle, you might want to run with the other 2 formula. If you don't, and you're just given the 3 sides, you're going to have to take your time and use Heron's formula. It's not difficult, but there are many steps, many simple steps. So now we go to the sine rule and the cosine rule, which you can use. The triangle doesn't have to be a right angle triangle, but you have to know particular information about them. So for example, to use the sine rule, you would have to be given, so the sine rule is A over sine A is equal to B over sine C equals C over sine C. You only need 2 parts of this formula. You don't need all 3 parts, but it's just showing you the relationship between the 3 sides. You can use any 2 of the 3. So you have to know 3 of the variables there, and so you can use it to find them. So you have to know 2 angles and a side, or 2 sides and an angle, and so on. And then you can cross multiply and divide to find the other one. For the cosine rule, likewise, you can use it to find the missing lengths or the missing angle of a triangle once you know the other 2 sides and the angle that's opposite to the side that you want to find. So there are technicalities to using the sine rule and the cosine rule. For each one, we're going to go in depth and to see how each was derived and so on, and when we use them. So all these formulae can definitely help us, and it's good that we know what we at all. There was a time when as these formulae did not exist. We did not know as a race, as a we did not know about these laws and these the formula that we can use, and the mathematicians who led us dedicated their lives and their time to working out these formulas, running experiments. So for example, just briefly, and we're going to go more in depth, but just briefly, is pi derived? Yes, yes, John.
Miss is like when the person who tried to create the light bulb, Missy dedicated his time. Missy finally made it work after 1,000 attempts.
Yes, exactly. And this is how it is for most of the things that we have around us. Take them for granted, and we have just the amount of time, effort, and patience, and sleepless nights. Some of these persons took their money, their own resources to buy material on these experiments. Now, this is something I want you to try at home, maybe tomorrow or on the weekend when you have the time. And this is how pi was derived. I want you to run your own experiments. I want you to at least 10 circles, at least 10 perfect circles. So whether it's a clock or you want to use a can or anything that has a circular shape, right? I want you to get your measuring tape. So you're going to set up a chart, a little table with the name of the items, the name of the 10 items, and you're going to measure the circumference and you're going to measure the diameter. So the reason why I'm saying you need a measuring tape is because they are circular, so you can't use a ruler to go around it. If you don't have a measuring tape, what way can you use to measure it using the ruler? You have any idea? Let's say you don't have a measuring tape at home and you want to know. Go ahead. Is that Imani or Amari? Go ahead and tell.
You can measure.
How can you get it?
You can put the long ruler like long ways and measure the inside of the circle, the diameter.
You're saying put a long ruler. What do you mean by to put it long ways?
So, like you have a tape roll, please. It's like you'd have the tape roll, for example, and you would measure the centimeters, the inside of the circle.
But how would that give me the circumference?
Because
that would give me the diameter.
And you would use the diameter in the circumference. In the you'd cut it into half and then put the radius value into the circumference formula and work it.
No, remember, we don't know the formula yet, This is an experiment, the formula. Let's say we didn't know anything about pi. So we don't have the circumference formula yet. We are about to derive formula. We're about to find out. So I'm saying, you don't have a measuring tape that can just go around what way can you use? What way can you that would still give you the accurate measurement of the circle? John, Amoy,
Yes,
any
miss.
ideas? Go and
Miss,
ask Zane if she has any ideas.
let's give it repeat the question.
I'm
So,
saying we're going to run an experiment. Say we don't have a measuring tape that can go all the way around the circle. Is there any other way we could find out the distance on the circle? If we have
miss,
a ruler, we have a ruler,
brown one.
or let's say we have a ruler and we have paper,
Yes,
or we have a piece of string. Can we find the distance around the circle? Let me tell you what you do. You can get the piece of string and run the string around the circle, get that measurement, and then put the string along the ruler. Or you can do the same thing with the paper, right? Just
yes,
run the paper around the circle to the from one end to the next and mark off where it stops. And then you put the paper along your ruler to see the measurement. So if you don't have a measuring tape, so I want you to get your 10 circles, write this of them, and then you're going to have a column for circumference and a column for diameter. Measure the circumference around the circle, measure the diameter, that's the distance across the middle, and then the final column you're going to divide the circumference by the diameter, and you're going to write down your answers. And then when you're finished, look at all the answers and tell me what you notice about them. So you're going to come back to this video in the comment section and tell me what your results are. That's your assignment.
yes,
Okay,
miss.
is it clear? Is it clear what you're going to do?
Yes,
Do you
miss.
understand the assignment?
Yes,
So you're going
miss.
to find 10 items that are circular. You're going to measure the distance around them, which is the circumference. You're going to measure the diameter, which is the distance across the middle. Record your findings. And then the last column, you're going to divide the circumference by the diameter and write what you find. You can put it in decimal form or fraction form. Write what you find, and then you're going to look at them and tell me what you notice about them. So we're going to wrap up this session now. This is our first formula class, the first of many. This is Thursday, so we're also going to have our Midnight Oil series. The very first of that series starts tonight from midnight to 2 a.m. We're going to do the CSEC paper 1, and this is going to be continuous. So every Thursday, the formula class from 8 to 9 p.m. and the Midnight Oil paper 1 multiple choice questions for CSEC from 12 to 2. So join me again for that class. You can go and have some rest, or if you're one of those nights you don't need any rest, you can just go do something else and come back at midnight. And we're going to comb through some of these paper 1, these multiple choices. I believe this has been my opinion from observation that most persons who fail the CSEC, their weakest point is the multiple choice. From with students over the years, conclusion, and in this series we cover all our bases. We do the paper 2, we do formula classes, do our topic by topic, we do our algebra and graph, each of those is a separate class during the week. But this multiple choice session is very important, and I think this is where most students fail because they tend to focus on the paper too, and many teachers too focus on the paper too. When doing their crash courses, focus on paper 2 questions, and a lot of students, they swap questions, they memorize it, and they're expecting the question to come the same time, and if it doesn't, they are lost. Paper 1, I have found some of these paper 1 questions, they call on things that you have done even from 5 and 6 and 7 coming up. Things that a lot of these students take for granted. So you have to sharpen your skill in percentage, in ratio, in fractions even. You have to have skills in all of these areas to master the paper 1. And bear in mind, you cannot use a calculator in the paper 1. So you have to be able to work these in your head or on paper, but without the help of a calculator. And for many students, they are completely lost without the calculator. We have to sharpen all the skills. So join me later, scholars. Thank you for spending the time with me, and I'm looking forward to seeing you again. So until then,
Bye, miss.
bye. See you later.